Yes, okay. So good. This is a project advised by Dr. Ji Chen, developing a smartphone app to collect and display health-related data collected from sensors.
So, good afternoon, everyone. My name is Glacia Martin, and my mentor is Dr. Ji Sheng. Introducing this project, I would like to draw your attention to the effects of COVID-19. In the early stages, there was no treatment, and patients that fell ill were sent home to quarantine. This called for remote health monitoring systems that did not exist. For the creation of such technology, we have considered it will be necessary for it to be able to connect to the Internet of Things. And we thought of how convenient it would be if medical professionals were able to monitor vital health signals from an app while the patient stays at home. Therefore, the title of our project was to design an app that monitors the data from a multisensory system. The objective of the project then became more advantageous and direct. The objective was to develop an app for home-based environment and health monitoring. Since the environment itself can affect a person's health, for example, a pollinating flower where someone has allergies, or a high temperature where someone has a fever, the app design goals were to use a microcontroller to collect multisensory data and send the data to an app on a smart Android-based device by Bluetooth. Another goal was to ensure that this data can be saved and sent to a cloud-based document for post-analysis. And lastly, to display useful information about the environment and a person's health. The methods we developed can be grouped into three main categories: sensors, data acquisition, and cloud-based data log. First, let's discuss the sensors. We chose to sense humidity, temperature, heart rate, and light sensitivity. A DHT11 sensor was used to sense room temperature and humidity. A photoresistor sensor was used to sense light level in the room, and a rotary potentiometer was used to simulate heart rate sensing. But how did we acquire the sensors? What the sensors sense? For our data acquisition method, we collected data from the sensors using Arduino microcontroller. The model that we chose to work with was Arduino Uno. Also, for data communication, we used MIT App Inventor and 806, with 806 serving as the Bluetooth of the device. For cloud-based data log, we use Google Sheet and AppScript from Google Drive. Following our method, we designed an app called EnviReport. The app was designed using blocks in MIT App Inventor, and it was developed with the idea of having multiple screens: the home screen, the UDC information screen, the data communication screen, and the Lockheed Martin information screen. I'll proceed to show the app blocks that were used in the app design. Block A at the top left of the diagram are the blocks used to enter into the data display screen. Block B at the right of the diagram is used to exit the data display screen, and block C are the blocks that were used for data display and Bluetooth connection. Together, these three sets of blocks allows for Bluetooth communication data display and screen manipulation. These are the blocks that are responsible for receiving and also for displaying data. These are the blocks that retrieve and send data. These are the blocks for logging data. And this is a circuit diagram designed in Fritzen. This shows the design plan for the circuit prototype we constructed. As a result of following our circuit design plan, this is what our final circuit prototype looks like. This is what the home screen of Inventor and its data display screen looks like. You will notice that there are two pictures for the data display screens. The screen labeled A is what the display screen looks like before Bluetooth connection, and the screen labeled B is what the display screen looks like after Bluetooth is connected. This way, we established connection is differentiated from no connection. This is the data login file. It is a Google Sheet consisting of 5 columns. Data is entered in this file in an orderly manner under the command of the app. It shows the temperature, humidity, brightness, and heart rate collected from the Adreno Uno by Bluetooth. There is a column for time, which shows the exact date and time at which the data was sent to the Google Sheet. Here is a video demonstrating how Enviroport works. As you can see, the app opens on the home screen. From there, you can click the Enviroport logo, which takes you to the display screen we talked about earlier. To connect to Bluetooth, you click the Bluetooth icon and choose the 806 Bluetooth. Device must be paired prior opening the app. After a connection is established, the data is displayed as discussed before. Notice that when the send button is pressed, the data appears on the Google Sheet. When the retrieve button is pressed, the last recorded data appears in the box below. Save data button allows for that to be saved but not sent to Google Sheet, and this data can be retrieved by pressing the retrieve button also. By pressing the back button, you'll exit the data display screen and enter the home screen. From here, you can learn about UDC mission statements. By pressing the Learn About UDC button, press back to exit to the home screen again, and select Learn About Lockheed Martin to see a statement from the creators and Lockheed Martin's mission statement. You press back to exit the home screen and back again to exit the app. Our project did have limitations. The first limitation we identified is that it would be better if we had Wi-Fi connection instead of Bluetooth, as this would be faster and we would have the opportunity to connect to more devices. The next limitation stemmed from the location of the circuit. The circuit would have to be mounted to the location where the changes of the parameters can be easily captured. Examine our limitations, we see where improvements can be made to our design. In order to use this technology in multiple rooms, it would be better to have a designated screen for each room. Another improvement could be to implement built-in control applications. And what this means is to give users the luxury of automation and control of appliances directly from the app. Another useful improvement could be to create an alarm function, and this could be in the form of a text message sent to your phone or tablet when your recorded heart rate falls out of a normal range. With all the improvements and limitations into consideration, this Enviroport can be a home automation and health monitoring system where room conditions such as room temperature, humidity, and room brightness could be monitored alongside vital signals such as heart rate, body temperature, and oxygen saturation. Envireport could be altered to control appliances and alert healthcare providers. With that thought in mind, our future work becomes clear. We could monitor health vital signs through clothing. Since patients can't be mounted to a fixed position, a smart suit could monitor active patients. In the future, if funded, we could design a smart hospital gown. The functionality includes placing the patient's finger on the section labeled B on the diagram, and this is where the oximeter will be placed for oxygen saturation and heart rate reading. Body temperature reading will be obtained from the section labeled A, and that would be where the body temperature is placed on their arm. For this suit to be ergonomic, it would be best if it were to be wireless. And this suit will also be able to connect to the Internet of Things, and as such would be an addition to the alert function. There are great advantages to having a smart suit. You might be thinking, why can't I just use an Apple Watch to achieve these functionalities? Well, for starters, the cheapest Apple Watch is $169, and it has limited functions. Bear in mind that this watch exclusively works with a single iPhone. With a smart suit projected cost of being $150 at most, and the Envireport app allowing for multiple patient monitoring simultaneously, this technology can be revolutionary. Think revolutionary. Just imagine a progressing world where the clothes you wear are not only for the purpose of fashion, but also to help improve your health. In conclusion of this project, we have tested the Envireport to collect data from a multisensory system. Envireport does home-based monitoring and health monitoring, and the save and retrieve functioned as it was intended to. The data was sent to the Google Sheet and properly displayed there as well. Given the evidence just presented, it is safe to say that our project was a success, and the future looks promising going forward. Special thanks to my mentor for the time he spent providing assistance and guidance. Also, thank you to the SEAS department and Lockheed Martin for making this experience possible. I am forever grateful. Do you have any questions for me?
Yeah, I got a question.
Go ahead.
Yeah. So, how did you develop that Envireport app? Maybe I missed it, but like, how'd you do that?
The Envireport app was developed using MIT App Inventor. It is a free software that lets you create an app in real time on the internet. You can save this app as a AI file. You can download it to your device that is Android based.
Mm. Okay, so you basically just uploaded that sensor data, like in that circuit, you just uploaded that sensor data into that app, right?
So the process is you set up the circuit,
Yeah.
you write your code in Adreno IDE, and then basically you tell what to do with the data that is collected from Adreno. The MIT App Inventor the app that you create allows you to show your data in whatever way you like, and it also gives you the opportunity to link this to a cloud-based data storage thingy. We chose to use Google Sheets and Google Apps Script, so we also had to write a code for Google Apps Script that allows you to connect your app to the Google Sheet. So you could send data. So the process is you collect the data using the sensors, microcontroller, send that to the app. The app then send that to the cloud-based storage.
Okay. I imagine that was the hardest part of the project.
Definitely. How did you know?
Hey, I failed twice.
Yes. We had to learn how to code in Google Apps Script in order to get it on the Google Sheet.
Gotcha. Okay, that's pretty cool.
Can I ask one question here?
Yeah, sure.
Yeah, go ahead, please.
How do you ensure the security of your app? You know, if there is any security mechanism that you put, you know, are there any security stuff that you put on top of the application, or security is not yet considered?
Okay, so definitely the Google Apps Script code that we wrote, we export it as a deployment, but you have to have an access code if you want to manipulate the data that is being sent to Google Sheet. It is a read-only file for persons who doesn't have any access to it. And so you wouldn't be able to just go in and get the data if it wasn't sent to you. It's just as if, you know how a normal Google Sheet work, you send a code, not a code, a link, but if you don't have a link, if you don't have a code, you can't get access to the data. And so it is very constricted to the specific app, the specific circuit, because of how it is coded. So the security really just comes from how we developed it using the code.
My concern is that, you know, during information exchange, you know, while the information is on its route, you know, from A to B, there could be any kind of threat there, you know. Just trusting the application might not be enough, just a suggestion. So I think it would have been better, you know, if you just go ahead and look at that side too.
Okay, so definitely I will take that into consideration and look at ways how we can reinforce the safety of our app. Thank you very much.
All right. Thank you.
Thank you, Lucia.